Hello and welcome back. This will be the first video on Section 4 of the Prerequisites chapter, and this chapter focuses on polynomials. So a polynomial, just a more precise definition, is just an expression that contains variables to whole number exponents. So, and remember, by whole numbers are things like 1, 2, 3, and so on, but they also include 0. So no negatives and nothing in between these integers. So no 1/2, no square root of 2, just these nice whole numbers. So an example of a polynomial could be something like 2 times x. Notice that the only variable in here, x, is being raised to the first power, which we don't normally write, say, to the first power there. But 1 is a whole number, so that's good. The next polynomial that I have here has 3 terms in it. The first has an x to the third power, 3 is a whole number. Next, x to the first power again, still a whole number, and then no x's. And I'll come back to this in a little bit, but these are both polynomials, and you can see that every x in the last polynomial is being raised to a whole number. There is no x there. So we have 3 examples of polynomials. What sorts of things aren't examples of polynomials? Well, we have 1 divided by x, and we've just learned that this is in fact equal to x to the negative 1 power. So because it's to the negative 1 power, this is not a polynomial. Also, the square root of x. Again, this is just going to be x to the 1/2 power. Again, not a polynomial because it's not a whole number. And then there are some other sorts of crazy functions like sine of x and things like this. These are not polynomials. It doesn't even look like a polynomial. So what can we say about polynomials? One thing in particular is the degree of a polynomial. So we'll look at a very simple polynomial first. If you ever have some number a times x to the nth power, n is the degree of the polynomial. Now, if a is 0, it doesn't look like a times x to the n, it just looks like the number 0, and the number 0, we don't consider that has a degree. So for instance, this first polynomial up here, 2 times x, the degree of this polynomial is 1. Because this is going to be x to the first power. So the degree of this first one is 1. Now this last one, I said, is a polynomial, so what is its degree? Well, one way to write 7 is to write it as 7 times x to the 0 power. And we have to stop and think for a second. Anything to the 0 power is just 1. So 7 times x to the 0 power is just 7 times 1, which is just 7. So when we look at the degree of this polynomial, the degree of this polynomial is 0. And in fact, the degree of any constant number is going to be 0, because we can always write it as 7 times x to the 0th power. But a polynomial may have more than one term, so what is the degree there? The degree is just going to be the greatest degree of each one of its terms. So in this polynomial, we have a degree 3 term, we have a degree 1 term, and a degree 0 term. The degree 3 term is the biggest one, so this is a degree 3 polynomial. And we can say a little bit more. Every polynomial is going to look like the following. I have a sub n minus 1, all the way down to a sub 2, a sub 1, a sub 0. These are just numbers, and rather than writing out a bunch of different letters, I've just given these numbers subscripts. So every polynomial will look like something times x to the n plus something times x to the n minus 1 plus all the way down through something times x plus a number by itself. These numbers here are called coefficients. And the first coefficient, the first one out here, is called the leading coefficient. This is the leading coefficient. Again, the degree of this polynomial, the largest number out here is going to be n. So this is the degree of the polynomial. And the very last term here with no x, or in fact x to the 0th power, this is called the constant term. Okay, so this is just breaking apart a polynomial and looking at its individual pieces. And polynomials, again, will just be representing numbers, and we can add and subtract these things. So let's go through a couple of examples. So let's add a couple of these polynomials. What you'll notice is that each polynomial is just made up of some terms, and perhaps one nice thing to do is to write all of these as addition. So the first term, or the first polynomial, x squared plus 1, I'm going to add that to the following. Rather than writing it as subtracting 3x, I'll write it as adding negative 3x. And while this isn't completely necessary, I think it's a little bit helpful to see that, oh, we've got a bunch of things that we're adding together, and we can combine these in like terms. So let's group these together. So x squared and a 2 times x squared, we'll be able to add these together. So let's put those at the front. Next, we have a term with an x, with just an x in it. And then lastly, we have some constant terms. We've got a plus 1 and a plus negative 7. So what you'll notice is that I've put all the biggest degree terms out front, and then the next, and then the smallest degree terms. So I'll just put them in order, so it's a little bit easier to read. And now I can start adding these. X squared plus 2x will be 3x squared. The plus negative 3x, I'll just write this as minus 3x. There's no other x terms. And then lastly, I have 1 plus negative 7. So this is negative 6. And I've added the polynomials. Also, this is completely reduced. So the next example will be subtracting polynomials. Just keeping in mind that we'll have to distribute this negative sign as we subtract each thing in the second polynomial. So again, I will turn everything here into adding. So the first term will be x cubed plus negative x squared plus 2. And now I'm going to subtract an x squared. And by subtract x squared, I mean add a minus x squared. I'm going to subtract 3x, but by subtract I mean adding negative 3x. And here I'm going to subtract negative 9. But rather than writing subtracting negative 9 down, I'm just going to say we're going to add 9. Again, subtracting a negative is the same thing as adding. So now I'll rearrange the terms so that we can combine like terms. The biggest degree, x to the 3rd power, is still up front. Then the x squareds will come next. Next, every term with just an x in it, and I think there's only this one here. And then lastly, all of the constant terms. So again, I've just arranged them in order, and we can add these up. X cubed, negative x squared, and negative x squared will end up being negative 2x squared. And again, I'll write it as subtraction now rather than adding. I'm going to add a negative 3x, which is the same thing as subtracting 3x. And then I'll add a 2 and a 9, which is the same thing as adding 11. Okay, so we've added and subtracted some polynomials. Let's look at multiplying. We'll look at 2 examples. The first one is fairly straightforward. 4x times this polynomial out here, and we will just need to distribute. So again, the way this works is I will need to take the term out front and multiply it against everything on the inside. So the first term, 4x squared times x cubed. The next term will be minus 4x squared times 6x. And then the last one plus 4x squared times 2. And then I can do each of these. 4x squared x cubed. When I multiply, I add the exponents. So this is 4x to the 5th. I will subtract 24. X squared and x will give me an x cubed. And then lastly, plus 8 x squared. The very last polynomials that will multiply. Now this first polynomial has 2 terms. And I think the easiest way to do this is to distribute each term individually. So I will first distribute the first term. So x being multiplied against everything in the second polynomial. Next, I will multiply everything by 2. It doesn't matter which way you distribute. If you want to distribute the x and the 2 like I have, or you could go backwards and distribute the x squared, the negative 2x, and the 1 instead. I've chosen this way because I felt like it. Next, we'll distribute all of these. So x times x squared will be x cubed. X times negative 2x will be negative 2x squared. X times 1 is x. So I've just distributed this x to each of those 3 terms, plus 2 times the first term here, plus 2 times negative 2x. So the negative sign will hang around, and I'll get negative 4x, and 2 times 1. And we are nearly done. We simply have to rearrange this and combine like terms. So our x cubed term is the biggest term here, so that'll stay out front. I have a minus 2x squared and a plus 2x squared. These will end up canceling out, but I've got my x squared terms next. The next smallest terms are going to be the terms with just a single x in them, so I've got x and minus 4x, and the constant term is last. So we can finish by looking at x cubed. Negative 2x and 2x cancel, so we don't have to write anything down. X minus 4x is negative 3x plus 2. In the next video, we'll look more at multiplying polynomials and do some more examples.